All right, packed house, I love it. Okay, so I am Robert Edwards. I'm the manager of software development at Glidewell Laboratories, and this is Galit, Gontar. She's a software engineer at Glidewell Laboratories. What we're going to present to you today is a generic workflow engine backed by Neo4j. Now, I feel like I need to give you some background because you may be asking yourself, what does a dental laboratory need with a workflow engine, much less a workflow engine backed by Neo4j? Raise your hand, or we'll make this a little interactive. Who knows what a dental laboratory produces? This guy's a plant, so if somebody else knows, and then we'll let him go.
I'm guessing it's probably pictures.
Effectively, we make teeth. And at Glidewell, we are one of the largest, if not the largest, dental laboratory in the world. It depends on which marketing department you believe. And to give you a sense of the size, 80% of the dental laboratories in the United States employ 12 people or less. And probably most of them you can fit in this room. And a lot of their workflows are pretty simple, right? If there's a case for Mikkel, I can probably spot it right over there and see that it's on the QC cart or something like that. At Glidewell, we have currently just over 4,500 employees. Our headquarters, our main lab is in Newport Beach, California, and 1 or 2 miles down the road in Irvine, we have our Irvine campus, which is about 7, 8, 9 buildings and growing. And so the ability to say, where's the case for Galit, and is, maybe it's right over there, is pretty much impossible for us. Another thing about the problems that we're trying to solve is teeth are very unique. It's kind of like manufacturing a snowflake. That sounded really good on the over here, so I ran with it. But just imagine it's like manufacturing a snowflake. And then throw in the fact that you can have different materials, different products, so dentures, like you were saying, the crown, bridge, implant. It's basically mass customization is what we're attempting to do. And something else that maybe will help you understand why we would even pursue something like this at our company is that we're vertically integrated, and that's great. When I say vertically integrated, we have our own chefs, they cater our parties, we have our own masseuse, we have our own gym, that kind of thing. And we do that not because it's like Silicon Valley cool. We do it because our leadership believes that if you have all the resources there at your disposal, you can innovate more quickly. And I know innovate, that's that word that everyone's using right now. I was telling Galit earlier, my grandma was telling me how she innovated something last week, and I was telling her, sprinkling sea salt flakes over sugar cookies is not exactly tasty at all, Grandma. But we truly believe it. We truly believe in innovation. So beyond the masseuse and the chef and all that, we have our own construction crews. And they build our cubicles, they build our desks, they take those spaces in one of those 7 buildings and reorganize it to our specification for whatever we want to do. We also have a team of material scientists. They create and research different materials, different processes for our future products. We have mechanical engineers that build the machines, like our mills, that mill out the blocks that our material scientists create. They build our robotics, they build our ovens even. We build our own ovens because that's how our people can test their theories. And then we have our own CAD/CAM software teams, and we have our internal lab management and CRM teams. And we do all this because innovation is really just an idea, right? It's a new idea. And we need to be able to test those ideas quickly so that when someone technical comes up with an idea, or even a receptionist, which has happened on occasion, we can implement that quickly and fail fast, another one of those terms that everyone's using nowadays. What gets in the way of that, so when I say vertical integration is great, it is. It creates expectation. Our leadership expects that we can move quickly. What tends to gum up the works for us is when we have to rely on human workflows. And I love humans. For the most part, I love humans. But when they have to take work, when we give them workflow decisions, we can run into trouble. Because someone can create, a subject matter expert can create a beautiful video diagram of a workflow and communicate that out to everyone. And you think about 7 buildings and other, headquarters in another location, that's very difficult. And then when you have to rely on those humans to make routing decisions, especially under pressure, it becomes more difficult. And it also limits our ability to have fine-grained variation in our workflows because it's just too much education, too much communication. And so all of that is why we pursued what we pursued. One, because we are an innovation company. We pride ourselves on that. New technology is something that we're not afraid of. And 2, because we need this as we move from a manufacturing company to a technology company. If you heard the talk, I forget his name, but from Marriott, he explained it, and I think a lot of companies are going through this. Marriott's moving from hospitality more into a technology company because they have to compete, and we're doing the same types of things. So that long-winded intro is to get you prepared for what you're going to see. I hope I didn't overhype that because there's not a lot of interaction to this. But now Galit will talk to you about our workflow engine.
Hi. So yeah, as Robert has said, our current manufacturing process is supported by an existing workflow system. So we do have a workflow system. But that system is very linear, it's very rigid, it's very inflexible. And frankly, at this point, because as we said, each tooth is a snowflake.
Okay.
Because there is so much customization inherent in our manufacturing process, this workflow system really is not representative of the reality inside our production facilities. I think it's useful to look at the timeline of an order as it moves its way through our production process. So as you can see, an order enters our production process in the receiving area. This is the point at which a technician receives a package from a dentist with materials for an order and some requests, etc. An order ends in the shipping area when all of the products in the order are completed, they get packaged up together, and they get shipped out. And in between the two, there is this big black cloud of uncertainty. And this is our current existing manufacturing process. And the reason it's so uncertain first is because our workflow system as it exists is so insufficient. Our technicians have created a lot of sub-processes, a lot of manual sub-processes, a lot of access database-based processes, right? To deal with all of the customizations and alterations and stuff that come up. And we have no visibility into any of that. And so what does this mean? This means that we know that there are bottlenecks in the system. We know that there are inefficiencies inherent in the system, but we cannot tell you what they are because we don't have any true visibility into the system itself, right? Additionally, we know that there are some issues with quality control that are inherent when you have a lot of human decision-making underpinning your processes, right? Because human beings make mistakes, right? A lot more so than an application with an automated process would. But we have no way to combat this. And so, what are the biggest drawbacks of the current workflow system that exists? First of all, because so much of our manufacturing processes are done manually, meaning are decided upon manually, are routed manually, there is no communication in between different departments, right? It's very hard to expose what is going on in manufacturing to other departments. So what does this mean? This means that if a customer calls a representative at Glidewell and asks about the status of the order, the representative knows some things. They know when the order arrived, and they have some estimate that an administrator kind of decided upon for how long it's going to take for the order to complete, but this estimate bears no relation really to reality because they don't know what went wrong and if there were any delays. They don't really know what's going on with the order. They don't have any real-time visibility into this order. So they can't tell you as a customer when your order is going to be delivered. And certainly you as a customer can't log in to an application and see when your order is going to be delivered. Additionally, as I said, there are unknown inefficiencies and bottlenecks within this process that occur when you have a lot of human people making decisions. And finally, as we grow the company and as we introduce more automation into our processes, it becomes really paramount that our workflow system accurately reflects what's going on in production. Otherwise, it's going to become increasingly difficult for us to scale and to automate and to innovate. So our team was tasked with developing a workflow engine, an application that would handle these workflows for the company. And we set for ourselves the following goals. First, we are going to attempt to improve the efficiency and the consistency of the manufacturing process by eliminating a lot of the human routing that's occurring right now. We're hoping that we're going to eliminate a lot of human error, and we're also going to impose a much more consistent process across all of those 79 facilities that we have across all of the places where we manufacture products. Next, we are hoping to improve visibility both internally, not just to customer service, but also to reporting departments, also to our engineers who might be running experiments inside our facilities and would like to see how an experiment is performing. Maybe we are routing some items through an automation process. We want to see how that's doing, as well as the executive teams, as well as externally to the customers themselves. And finally, we would like to allow our business to make much more intelligent and data-driven decisions, so that when we are modifying the process, when we are introducing new product lines, when we are automating, we know that we are making decisions with some data behind us, right? Not just our feelings. So the cornerstone of these applications that we built was a Neo4j database that housed all of the actual live workflow data. Now, why did we go with Neo4j rather than a relational database, which is what we have now? Well, there were a few reasons. First of all, what is a workflow? A workflow is really a sequence of processes connected by relationships going on after the other. And Neo4j permitted us to express this in the most expressive, sort of natural way. And that was a benefit for us. Next, our business needs are really complex now, and they are really always evolving and changing. We could not make a full understanding of our domain before we build this application, and you really have to do that when you're working in a relational database. With Neo4j, we are able to kind of create a workflow engine now, and when our data changes, when we introduce new processes, when we introduce new types of workflows, we don't have to restructure all of our existing data, because it has the flexible data model. And finally, the main need for this application is to allow our orders to traverse complex connected graphs. The advantage in performance that Neo4j provides over a relational database that would require a lot of complex queries and joins and stuff is really important for us. So I think a helpful way for me to think about this has been that what we are really doing is extending a really classic use case of Neo4j, which is the real-time recommendation engine. Now, what's a real-time recommendation engine do? It takes in the user data, the user's profile, the user's past purchases, their preferences, etc. And it uses this information to make decisions about what to recommend this user in the future. Similarly, what does a workflow engine do? It takes an order, information about that order, what products are in the order, what materials are identified, who the customer is, what that customer's preferences are, like what technician this customer would prefer to work with, what technician this customer refuses to work with, things like that. And it uses this information to most appropriately route the customer into the best workflow for them. So to go a little bit over the architecture of the workflow creation component of our application, we decided to go with the polyglot persistence model. So we use Neo4j for the live database, right, for all the reasons I explained earlier. But we use MongoDB document store for the workflow catalog, which includes all of the metadata about the workflow, for example, who created this workflow, when it was created, etc., as well as versioning and information such as when to activate this workflow, when to deactivate this workflow, things like that. And we do that because when you edit the workflow, it just makes more sense to get all of that data in bulk. It's less expensive than having to traverse the workflow in Neo4j to get that data. So for the workflow engine schema, we worked with this really great consulting company called Glidewell. Yeah, and they helped us a lot to come up with a really simple and a really generic workflow schema for our application. So the workflow consists of processes, and each process has tasks. The tasks execute when a process is activated, meaning an item traversing the workflow lands on this process. The tasks execute, they can execute asynchronously, meaning they all execute at once, or synchronously, meaning the second executes after the first is successfully completed. The processes can be connected by default, or they can be connected by some conditional set of values, for example. So depending on some parameters on the item that's on process 1, it will either be routed to process 2 or to process 1A. Similarly, depending on how a task fails, that will determine the way it is routed to a failure process, right? So, as you can see, process 3 on rejection goes to process 1A. So for me, this is very abstract, right? And so an analogy I like to use is baking a cake. So how do you bake a cake, right? And don't argue with me that this is not how you bake a cake.
She doesn't know how to bake.
I don't actually know. I did this for my boyfriend, and he was like, that's not how you bake a cake. But fine, just go with me. So you start with the dry ingredients, right? You put flour, you add baking soda, then you add salt, and you mix it together. Then you move to the wet ingredients, the eggs, and you beat them together with sugar. When that's done, you move on, and you combine the ingredients in the mixer, and you make a batter. But what if you are making a chocolate cake instead, right? Then you are routed after the wet ingredients to an alternate step. You add the cocoa powder, then you go to the mixer. After that, you pour the ingredients, and then you bake. Oh, but what if when you are pouring the ingredients, you notice that you're completely liquid batter, you didn't add any dry ingredients? Well, you go to you failed, you go to a conditional fail step, and you add the dry ingredients, and you go through it again. So what are the benefits of this for us? First of all, we love the fact that this workflow engine is so generic that it can accommodate really any type of workflow. Anything can be a process, right? And you can route this process any way you want. Second of all, this workflow engine allows us to create workflows that are modular and reusable. So rather than having to be a subject matter expert on some huge process from beginning to end, we can split up this workflow by department and have different people create different small workflows that we can reuse and chain together in a way that's kind of customizable depending on the implementation. And finally, most importantly, our current workflow is linear. They go from A to B to C. The teeth are not linear. And so the fact that this workflow engine allows us accommodate conditional workflow processes and conditional failure steps was very important to us. So here is an example of a real product that we actually manufacture in a real product workflow, a really simplified product workflow. This is a product called Roxer Solid Zirconia Single. It's a crown. It begins at the impression stage. If you've ever had a dentist make a crown for you, they take a model of your mouth, right? They send that into us. So at the impression stage, a technician opens the package and gets this model. Then it goes on from a number of steps, plaster, dye trees, and scan. And this is the point at which we create a digital representation of the crown we're going to actually create for you. Then we move to milling, which is when we mill an actual crown out of material, either manually or with a robot. And then finally, we glaze it and then we ship it out to the customer. But what if something different happens? What if when you open the RX, right, for the open package at the impression stage, and you see it says, call the customer before proceeding. So now, a human being would see that, and either it would go and happen, there would be a delay, and we'd have no way of accounting for it. Or a human being would see that, would not know what to do with it, the product would get made, shipped out, the customer would receive it, go, oh my gosh, you didn't call me, send it back, and be really angry with us. Now, because we have the automatic workflow, a technician says, okay, it says call customer, it gets routed to a call customer sub workflow, upon completion, it gets sent back. What if we mill the wrong tooth? The technician notices that after we've made the tooth, it's the wrong tooth, okay? Again, in the new system, it becomes an entirely automatic workflow. It gets sent back to the appropriate stage and recreated. And we can zoom out because our workflows. Can you see this? So if you can't see
Can
this.
you see that?
Okay, cool. I can see. Okay. Because our workflows are so modular, we can chain the different workflows together. In reality, the product workflow is a small part of the entire order, right? Each order has multiple product workflows for every product that the dentist ordered. And so we are able to chain these different workflows together into an entire end-to-end order workflow using the workflow engine. So just visually, for comparison, I think it's very helpful to compare this new product lifecycle with the old one, and how much more fine-grained the data you can see this, and how much more detailed it is, and how much more complete our understanding of the workflow can be now. So, as you can see, we can, because we have this fine-grained data, a manager on the floor or an individual in the reporting team is able to see a product's entire path as it moves through the order. Which alterations were required, which processes failed and had to be sent back and redone, who was in charge of this process at every step of the way, and how long each of those processes took. And we are also, because this information isn't useful or even suitable to most users, we are also able to filter this data and to present it in a way that is most useful and comprehensible to different users. So a customer service representative needs a different subset of this information than a shipping floor manager, for example, and they will get a different subset of this data. So we are still in the really very early steps of implementing this actual workflow engine in the production process. But in the meantime, because this workflow engine is so generic, we have been able to implement it in a completely different way inside our application deployment, automatic deployment process inside engineering department. So as you can see, with no code changes, it's a very similar process. When a user says, okay, deploy this Docker image, that initializes the workflow. From there it goes, it knows to push the image to AWS, proceed to some checklist steps, check that this user is qualified to deploy, go through some pre-deployment steps, deploy the item, and then finally confirm with the user that the item has been deployed. We were able to do this with no code change to the workflow engine, just by changing the kind of data and the kinds of tasks that the workflow engine does. And this has allowed us to make our deployment process a lot more flexible, a lot easier to replicate across different environments, etc. So moving on to the architecture. You've seen the architecture on the left. This is the workflow creation part, and it culminates in the Neo4j graph, which houses all of the live workflow data. Now on the right, you can see the actual workflow services. The workflow engine service has all of the business logic for the workflow. It accepts items from a configurable set of processes, pushes those items into the Neo4j graph, receives back which process is active and what its tasks are, executes these tasks depending on the task definition. The task itself contains its own execution instructions, gathers the results, and sends them back and routes the item on its way through the workflow. And any number of web clients can have a socket connection to the workflow engine to collect an appropriate subset of this data as the item is routed through the workflow. And so just to close this out, I wanted to show you some screenshots of what this application actually looks like for us. So for example, this is the page for designing the workflow itself. And on the left, you see a list of all of the products. There's another page with a list of all of the processes. An administrator is able to drag in different processes, edit them. As you can see, plaster is selected, plaster is being edited. Assign task sets. Each task set will be executed asynchronously, but all the tasks inside the task set will be executed sequentially. And so you can see plaster, for example, will have pin or an articulate execute sequentially, but pin and soft tissue will execute at the same time. Here you see the manager view. This is the floor manager. On the left is the list of pending items. These are all the items that have completed their previous workflow step, have been routed to the next workflow step, and now need to be assigned to a specific user. And so in the middle you see a list of all of the users who are qualified for this specific step. And so all the manager has to do is check one, and it will automatically be routed to their workflow. And then on the far right, you can see the current processes list. The system manager can see all of the technicians, what product they're working on, what process in that product they're working on, and how much time they have to spend if they have been working on it so far, divided by how much time we thought this process should take. And in red, you see those people who have gone over the allotted time. And here is the technician, sorry? And here is the technician view. You see the technician themselves. They see the pending items are the items actually on their desk right now. They select in proxy solid zirconia single, and you can see they can select, and you can see the tasks for that plaster process. They can mark the task as completed, or they can mark it as rejected, and then they have to provide the rejection reason depending on what the reason is. We will round it to a different failure process. On the bottom, all our technicians are paid at piece rate. That means they get paid for every item they produce. Now we are now able to, in real time, track how many items they have completed so far. And so you can see on the bottom a list of all of the items, units that this person has completed, and their running total. And finally, as I said, analytics is a really important part of this application, gathering data and displaying it. This is not real data. I have to tell you this, right? Because, so this is just test data for demonstration purposes. But you can see we are able to use this aggregate all of our workflow data to show an executive person or a reporting person how many orders we've received today, how many products are currently in production, how many products have been completed today, divided by how many products we would like to complete this far today, etc., etc. So in conclusion, what we have learned is that for these kinds of really foundational systems in your company, it is really useful to go with a really generic solution because you don't know where you're going to be able to implement them once you have it. And then finally, to try to create modular processes that way you are able to split them from different people. You don't have to have, you don't need to create subject matter experts that know every single thing about the process because you did it across different people. And that's it. Thank you very much. You guys have any questions? Yes?
Well, company, do you guys have any idea how much money?
A gazillion dollars.
It's actually kind of hard to say, and the reason is because I think this process, this implementation is going to go hand in hand with a lot of other automation processes that we're going to be introducing in the next couple of years. So we're going to save lots and lots of money, but we don't know how much specifically for the project.
But to give you, well, not an idea of how much money we'll save, but as one of the largest, again, in the world, we have 6%, I believe, of the U.S. market. And so there's lots of opportunities for us. And we would like to take advantage of that opportunity without increasing headcount. A lot of people that we currently have that are making teams or doing other things can be transitioned to other jobs. And so that's really the big opportunity for us. We get that fine-grained information for our customers, and we're able to now turn around our product a lot faster.
But you're very confident that you will save money.
And that's what I tell my boss. Yes, sir.
This looks a lot like lead manufacturing. Are you subscribers to lead?
Oh, yes, we are. Now, we don't, we're agile in the engineering department, but on the production floor, yes, they have their signs up everywhere, and they run a clean shop. We do have a lot of lean initiatives.
It's a full system.
See now, I can tell you about Agile Scrum, I can't tell you about Lean. Yeah, that's something that happens under production. Oh, you mean for our? Yes, yes.
Not directly, they pull.
Yeah, for our system, yes.
Can you name some of the big bottlenecks? And eliminate?
As I said, we are in the earlier stages of implementing this thing. So we've created the software, but we have not yet actually implemented it in production.
Yeah, we've only implemented it in that deployment system.
In that deployment system.
Instrumentation, you're about 50%.
Oh, in implementation?
Are you talking about just this or just across the company?
Oh, yeah.
I mean, everything we're doing is happening so rapidly. We have a lot of machine learning and artificial intelligence initiatives as well. So a lot of the processes that you've even seen there, like design or scanning, are going to be transitioned to automation. So there's many different departments. We're one group. There's, like I said, CAD/CAM is another group. We're all working together.
That workflow tool you showed was pretty neat. Is there any like source that?
Yeah.
Yes,
Yes,
there might be.
yeah,
We'll find out later. But yeah, you know, again, this is something for us that is really new. We were just 2 years ago pretty much a .NET shop across the board. And now only thing .NET that we use is the language C#, and we're even starting to open up, you know, we have WebSocket services written in Node. And so, yeah, we are looking towards being more dynamic and open sourcing things as well.
The web UI, have you guys developed in-house or?
Yeah. Yeah, we develop everything in-house.
I think that one is her favorite, D3. Is that your favorite?
D3, yes.
She hates D3.
I really hate D3. So we are looking, actually there is one of the little tables out there, I forget the name. Excuse me? Key something? Yeah, Keyline, yeah. Apparently they do an alternative to D3. D3 is terrible, don't use D3. Learn from my mistakes. It's a lot of work for really very little gain. But apparently they've developed something that's specifically for graphs, so I check that out.
She's not opinionated at all.
So just for to understand your reach, your favorite application, so each node for the process.
Yes.
And then those things will flow down to the
Tasks. They were tasks. Yeah.
Okay, great.
So yes, so tasks are little nodes that contain in them which endpoint we should hit, which API, and then what we should expect back as a success kind of thing. And so they're really, really flexible for us, right? So they allow us to, and so we have to kind of, they allow us to hit any API, any other system, etc.
To give you an example, so for that deployment system, we could actually say, okay, after we've actually deployed it into production, is anyone familiar with Run Scope? It's an automated API testing tool we use, so we can call it's software as a service. We can call one of their endpoints, pull down a set of tests, and begin to run those tests.
Exactly, yeah, and expect like, okay, failure rate is more than 4. For example, we can have like a really detailed response expectation. Then go into that failure process. If it's less than 2, then go into that process.
And if we decide one day Run Scope costs too much, or there's another one that Postman that we use internally sometimes, we can decide that we want to hit that API instead. That's a workflow update, and then on the next one.
Yeah, we don't have to update. It used to be that deployment tool was like a service. So you have to pull down the service and update some code and redeploy it, and this allows us to kind of get around that really easily. That's it? Okay.